Good morning. Today we will be doing experiment number 6. The title of this particular experiment is Bond Lab. Before I start the instructions for the Bond Lab, I would like to give you some general information. After the completion of Lab 6, you need to know and be reminded that you will have a midterm exam. The midterm exam will consist of questions from experiment number 1 through 6. And so please go through these experiments in order to ensure that you know all the laws, the equations, the concepts, and how to solve the problems so that you can get a good score in your midterm exam. The midterm exam will be a multiple choice question and will, in terms of your lecture classes, they will consist of content from chapter number 10, gases, and chapter number 11, intermolecular attractive forces. And with that, I'm going to start the Bond Lab E6. Bonding is one of the most interesting topics in chemistry because a bond is a relation between two different atoms. And the type of bond that arises depends upon how this relationship between the different atoms exists. The bonds are formed either by sharing sharing electrons, or by loss and gain of electrons, or in some cases, a pair of electrons can be donated from one molecule to another or from one ion to another. Now, first, let's name these bond types that you have. If there is a sharing of electrons between two atoms, the question comes, where do these electrons come from? And we go straight back to the periodic table, where each element is placed in a particular column. The group numbers on top of the column indicates what we call as the valence shell. The valence shell represents the electrons in the outermost shell that is available for bond forming. This means that no matter whatever type of atom you have, which is considered as a multi-electron system, only the outermost electrons are available for bond forming, and the inner electrons do not or are not involved in bond formation. So if you have an electron, if you have elements from group 1, 2, and 3, then we know that these elements from group 1, 2, and 3 can readily lose their electrons, with group 1 being highly reactive, group 2 is a little bit less reactive, and group 3 is further less reactive. However, trying to take out 4 electrons, 5, 6, and 7 electrons is going to be extremely hard because the energy required is very high. This is because as soon as you remove an electron, the number of protons on that particular atom is greater than the number of electrons, and so it becomes a charged particle. And to remove an electron from a charged particle is extremely difficult. Furthermore, the loss or gain of an electron is such that the total sum of the electrons in the outermost shell will be such that it is equal to either 2 electrons, that is, the shell completes a duplet, 2 electrons, or it completes an octet, 8 electrons that are there. Gain of electrons is called as reduction. Loss of electrons is called as oxidation. And loss and gain of electrons results in the formation of what we call as an ionic bond. An ionic bond is an electrostatic bond between the cation, an ion that has lost an electron, and an anion, an element that has gained an electron that is there. Now, the next type of bond is called as the covalent bond. The covalent bond is involved between elements group numbers 4, 5, 6, and 7. 6 and 7, that is there. They are formed by sharing of electrons, and these electrons are shared so as to complete the number 8, which is the universal charge for any atom that is present. So the bond formation always comes back to this concept that every atom either tries to complete its duplet, and the duplet is only for hydrogen because all other elements can form other types of bond. A duplet, that means 2 electrons maximum in the outer shell, because helium is the first inert gas and it is atomic number 2. Rest of the elements will try to complete an octet so that they represent the following inert gas structure or the preceding inert gas structure, because the outermost shell must have 8 electrons. Now, if one pair of electrons is shared, then we call it a single covalent bond. If 2 pairs of electrons are shared, we call that as a double covalent bond. And if 3 pairs of electrons are shared, then we call it as a triple covalent bond. So now we have completed the ionic bond and the covalent. The third type of bond that normally students come across is what we call as the coordinate covalent bond. As you go to a higher topics in chemistry, you come to these particular structures that are there, wherein one molecule or an ion can donate a pair of electrons, and then this donating a pair of electrons from one to the other is a directional bond. As soon as you have a directional bond, then you have the cause or the reason to say from who gives from and to. And this will also result in identifying the geometry of the molecule that results. And the last type of bonding is called as the metallic bonding, because the metals are very, very stable. And we know that many metals do not complete their octet, but yet they are very stable. And this is because the electrons associated with a metal atoms flow all over the place on the surface, top and below, side, left side, right side, making a sea of electrons, such that an electron from in a given metal is not exactly associated with the specific atom, but it is common through all. How do we know that such a type of electron exists? If you have studied the magnetic property, then you know that the flow of electrons will set the direction of the flow of the poles. Magnetic poles are obtained, and so you can get a pattern just by moving the magnet so that you can align the electrons one after the other, remembering that metals are good conductors of electricity, and therefore they must have electrons that will flow. Why? Because electric current is defined as the flow of electrons. Now, with that brief introduction, I have to now go to why is it important to study the bonding? Because it is important because bonding gives characteristic physical properties. And it is these physical properties that can be used to classify the nature of a compound that results. And so in this particular experiment, we are going to do 3 types of characterization. We are going to find out the melting point of a compound, solubility of a compound in different solvents, and then we are also going to measure conductivity, because a compound that dissolves in water will not exist in its solid form, but will always exist in the form of its cation and anion. Existence of a cation and anion will allow the solution to conduct electricity, and therefore you get the conducting results that are there. And in order to go through this experiment now, I will be sharing the document, the experiment, and performing only one set of the experiment so that you can do the remaining part by yourself. And then the aim of the experiment is you are given a series of compounds. You have to differentiate between the ionic compound, the covalent compound, but based on the properties that you have studied, the physical properties that you have studied. Now, remember, in General Chemistry 101, physical properties are those properties that do not change the makeup of a substance. So that is very, very important to remember. And with that, I'm going to open the share. Go to the file and open the Bond Lab. And there you go. You have the introduction. Again, I'm repeating the same thing. We are going to learn or study the properties of the ionic and covalent compounds. And these bonds, compounds, the compounds are held by either ionic bond or covalent bond. And I've already described the bonds to you. Read the instruction. Remember always to write the introduction for your lab report in your own words, indicating that you have read the lab. Now, there are a series of compounds, as I told you. And so we go to the procedure, and I will do only one. So you can see there are 6 different compounds that are there. And I'm just going to show you one, and you go on repeating each one set, one after the other, and then go and proceed on to the next part. And this particular experiment has part A, B, C, D. Remember to do all the parts, and for each part, you have to take the picture of the experiment with its data and copy and paste it into your Word document so that I can see and ensure that you have done it correctly in order to justify the scores that I present. Now, all your observations must be completed under the observation table. The observation table is the only item that can be copied and pasted directly from this experiment onto your lab report, because it indicates the values that you have derived. And so first part, so I'm going to get a watch glass. So go to the equipment and find out a watch glass. I've got the watch glass. And then I'm also going to go and get a balance, an electronic balance, because they say they need me to put 2 grams of the compound. Or if you don't want, you just click it and you can directly go to the compound and enter the mass over there. So there is no need for an electronic balance. Just directly enter the mass required and say, okay. So now we have, I'm going to delete that balance. So we have the compound, the first compound inside it. Next, I'm going to get a Bunsen burner and keep it below that and start heating it. And then record what you see under observation. So that completes the first part. That is there. So don't do it for a fraction of a second. Let it stand there for some time and record whether the compound is melting or not melting and which compound. So you set up a series of 6 experiments, one after the other as indicated in the procedure, and then keep 6 burners below each one. Below each watch glass, keep a burner, so you will have 6 burners, and then you find out which compound melts first, second, third, fourth, fifth, and sixth, etc., and record that. After that, once you record it, remember to highlight it, copy and paste it into your copy and paste the set into your lab report. Then you clean up the workspace. So you clean up. How do you clean up the workspace? Just highlight and click delete. That's how you clean up your workspace. Next, you get 2 test tubes. Per sample, you get 2 test tubes. So get 2 test tubes, keep them apart so that you know in one test tube, you add, first you add 2 grams of the compound in each test tube. For every experiment, you are going to get 2 test tubes. So, and in both of them, you're going to add 2 grams of the compound. So that way you don't mistake it. Now, if you think you're going to make a mistake, then what you do is set up 2 different rows, one below the other. So in one row, the first row, you're going to add 25 mLs of water. And then in the second test tube, you're going to add 25 mLs of ethanol. So you add 25 mLs of ethanol. Then what you do, take a stirrer, put it in the first flask, a stirring rod, and stir it, and see what happens. Once the stirrer stops, you go get another stirring rod and do the same in the alcohol. And what do you see? Whatever you see, you record it under your observation tape. So you have your solubility for first the melting point, then the solubility in water, solubility in ethanol, and do it for all the compounds. You fill up your result. After you fill it up, then again, you remember to copy and paste the pictures. Then once you do it, clean up your table. Then you go to the procedure for the conductivity. So you get Go to the equipment, get 100 ml beaker. In this 100 ml beaker, you add 50 mLs Go to the chemical, add water 50 mLs, 50 mLs, then you say, okay. And into this, you add 2 grams of the chemical, starting from the first one. Make sure you add 2 grams of the chemical and say, okay, now go to the equipment and get the conductivity set up. Check whether conductivity meter is there. So now, first you stir this, stir the beaker, stir it so that the compound dissolves, or as much of the compound can dissolve it. Once the stirring rod stops and goes back to its place, then what you do is you make sure, arrange the conductivity meter properly so that you can combine the two and say, oops, what happened? Just one minute, please stand up, change, measure and record. Okay. Should come inside. Conductivity. Oh, sorry. Okay, I made a mess in this, so I'm going to redo this particular setup because I just added 2 grams, and I can correct that here. And go to chemicals. And since I added 2 grams, I can add an additional 8 grams so as to make it 10 grams and say, okay, then I'm going to stir it. So once you combine it, you can see that. So after you add the 10 grams of the salt or compound, stir it, then just place the conductivity meter on top of it, combine, and then record whatever the reading is. And repeat it for each of the compounds that you have taken. And with that, once you finish that, then you go back, enter all the details, and then classify it. Then you complete from the data, you analyze and group the compounds as per whatever they ask you to do separately. So once you finish all this, then if I were you, I would do a table containing the names of the compounds, and then I will put in exactly like this, four columns, 5 columns on the table. The name, and on the first column, the heading will be name of the compound. Second column, melting point. Third column, solubility in water. Fourth column, solubility in ethanol. Fifth column, conductivity. So now that's your table number 1. As soon as you put that in, then you classify them. Low melting point, group 1, consists of whatever characteristics they are looking at. low melting point, soluble in ethanol, not conductive. Then group 2, high melting point, soluble in water, conductive. Put it in that for each of these and label them. So you will have your table with all of it, and you can put the last column, you will add like whether it is a group 1, group 2. You classify it into 2 groups, followed by your, from this, following this, you write down which one is the ionic compound and the covalent compound. And this particular table will be used to describe or define your results for the experiment, and which will be the make sure that the objectives are met, completed, and then use that for discussing based on the type of bond that is there. Now, if you want to see, okay, I'm going to do another share so that, just 1 second. No, just let me close that and let me see. I have a Word document, so I'm going to open it, and then I'm going to open an Excel sheet, open that, then highlight the columns I want, 1, 2, 3, 4, 5, 6, and 7. I'll say copy and turn it over and say table 1, table 1, table 1, and then classification of compounds into groups. And then I'm going to enter, paste my document. Okay, make sure you can see the columns. So now you can see it. I'm going to expand it so that you can very clearly see. The first one will be name of the compound, name of compound. Then the second one will be melting point, and each factor you put in. So solubility water, solubility ethanol, then this will be in conductivity measurements, which conductivity is also always measured in microsiemens. And so you write down that, and then you say group 1, groups. You classify in groups, or you can write group classification. And then lastly, nature of the bond, and complete this, and you will have a beautiful table which can be used to discuss your compound, your experiment thoroughly well. So make sure you have that nicely done. And once you have that, then everything is done, and the experiment is over. Complete the homework, follow the template to